Good afternoon, students. This lecture is done for our power electronic and motor control system students of its NCT. Uh, Today I am going to discuss you about the converters, uh, which is part B in our syllabus. Here you can see the topic: power electronic converters. Mainly we have four types of converters: AC to DC converters, DC to DC converters, then AC to AC converters, then DC to AC converters. Here we have terms AC and DC. So we have four combinations among these two terms, right? Which is 2 to the power number of terms 2 equals 4, right? You can see here four combinations, right? AC to DC, DC to DC, AC to AC, and DC to AC, right? AC to DC converters are called rectifiers, and DC to DC converters are called choppers. AC to AC converters are called cycloconverters, and DC to AC converters are called inverters, right? These are the types of power electronic converters. Right? Today I am going to discuss with you about this converter, AC to DC converter. Simply you can call rectifiers, right? Rectifiers. I am going to discuss with you thyristor based full wave AC to DC converter or rectifier, right? Let's draw first the circuit diagram of that converter. Here we are using thyristors or SCRs. Then we have our input voltage, right? Then load. Let's consider first the resistive load. This is my input voltage V in, and then let's take the output voltage or the voltage across this resistive load as V out, right? Let's mark here thyristor 1, thyristor 2, thyristor 3, and thyristor 4, right? Then these thyristors are controlled by a special circuit called the Afl.Eng controller, right? let's draw that here. Firing control circuit, right? Then we connect the gate terminal of these thyristors with this firing control circuit, right? Then we are going to draw the output waveform of this converter with respect to the input voltage. I'll draw that here. Let's take the x-axis as the angle axis and y-axis as my input voltage V in. Then with respect to that, we draw the output voltage V out, right? The nature of the input voltage is sinusoidal. Let's take the peak value as Vm or maximum value, and with respect to this we are going to plot the output voltage of the converter, right? The arrangement is full wave, right? I think you already know about the full wave rectifier circuit, right? This arrangement same as that full wave rectifier circuit, right? Then let's first mark here the full wave rectified waveform. Right here, peak value Vm, it does not change, right? Then according to the firing signals issued by this control circuit, thyristors will fire with a systematic manner. Let's say first we fire TH1 and TH2, these two thyristors. Then your waveform looks like this, right? This is for the operation of thyristor 1 and thyristor 2, right? Then we fire TH3 and TH4, right? This is for TH3 and TH4, right? Let's take the firing angle of this circuit as alpha. Then here also we have alpha. Then again we have the result of TH1 and TH2, TH1 and TH2, right? Like that we can fire simultaneously, right? Right here the output voltage is fluctuating like this, so we can define an average value for this kind of a waveform. Let's take that as AVG. V average voltage of the output voltage. Right? The average value, this average value can be written as V average equals Vm divided by phi 1 plus cos alpha. Right? You can prove this using integration, right? But in this level we directly use this relation to solve the problems in your final paper. Right? You can note here, when alpha increases, the average value decreases, right? So by controlling this alpha, we can control the average value of this converter, right, or the output voltage of the converter. Right? So this can be used as a motor controller, right? Suppose you want to control the speed of a motor, right? Then you can use this kind of a AC to DC converter to control the speed of the motor, right? There we control this alpha, firing angle, right? So the range of alpha, if you take the range of alpha, the range will be from 0 to 5. Alpha range is greater than or equal 0, less than or equal 5. So this is the range. Alpha greater than 0, less than 5. Right? So that's all about the basics of this AC to DC converter. Right? I think this lesson is clear to you. If you have problems, you can comment under this video.